This is our last video for our unit, and this one is on factoring linear expressions. Our essential question is, how is the GCF used to factor expressions?
Okay, so let's remember what factors are. Greatest common factor would be the factor that is the largest among the two numbers. So,
Just in case they forget what GCF stood for.
We're going to look at 12 first, and we're going to ask ourselves what times what is equal to 12. So we'd have 1 times 12. Are you making a rainbow for them, or what you going to do?
I'm going to list them out.
1 times 12, 2 times 6, 3 times 4. All right, 30 would be 1 times 30, 2 times 15, 3 times 10, 5 times 6. So remember, when you get to the point where the numbers are turning around, you are done, and hopefully you've gotten all the factors. Now we're going to make sure that we have the largest number that they have in common, and in this case, it's going to be 6. 6 is on both lists, so the greatest common factor of 30 and 12 is 6. Hopefully this is coming back to you. All right, this time we have the expression 16x and the number 20. So we're going to do 1 times 16, 2 times 8, and 4. Now, 20 does not have an x, so we cannot...
I'm going to list it as one of those factors because it's one of the pieces.
Right. They won't have it in common, but we cannot ignore it, is what I was just going to say. Okay, 1 times 20, 2 times 10, 4 times 5. There's the turnaround, so we are done. We look for the greatest common factor, and in this case, it would be 4. GCF equals 4. Moving on.
All right, so now we're going to put that into use to factor an expression. So you're going to fill in a little bit in your notes. Factoring an expression is like the distributive property in reverse. So you're kind of, instead of multiplying a number on the outside, we're actually going to pull that number out to the outside. Mrs. King's going to sneeze. Just wait for it. Okay, the key is you're going to divide out any factors that the two terms have in common. So the best way to start is to look at your two terms and try to decide what's the biggest number they could each be divided by. In this case, that's going to be 4. 4 and 28 can each be divided by 4. So what we're going to do is we're going to break down each of these numbers using that greatest common factor. So we're going to take the 4, and then you ask yourself, what would I multiply times 4 to get to 4x? That would be x. And then my 4 again, 4 times what gives me 28? That would be a 7. That factor that they had in common, that number is going to slide out front. We're going to pull that outside of the expression. The leftover pieces are going to stay inside. So the x plus 7 is going to stay on the inside. That number that they could both be divided by is what gets pulled out front. What's left over is what's going to stay inside of the parentheses. So like we said, it's going to kind of look like a distributive property problem. When you get to the very end, that's how you know you're finished.
Oh, nicely done. All right, so in the next example, we're looking at what does negative 36 and 24 have in common. So the greatest common factor would probably be 12. Many of you would have put 6, though.
Yes, you always have to go with the biggest factor.
So we're going to put a 12 on both sides. 12 times what would give us negative 36y? So we're going to go ahead and answer negative 3y.
Don't forget that variable.
12 times what is going to give us 24? So we're going to go ahead and answer 2. So the 12 is going to go outside the parentheses. The negative 3 has to come along for the first term. So negative 3y plus is the operation that's carried into the parentheses, and then the other term is 2.
All right, next one. Remember when we see that subtraction, changing it to adding the opposite. And then we look at both negative 6 and negative 15. What do they both have in common? Here's where you want to be careful. They're both negative numbers, so they have that negative sign in common. And then 6 and 15 both can be divided by 3. So we have that common factor of negative 3 for each of our terms. Then we look at what would I multiply to get to those terms. So negative 3 times what is negative 6x? Well, negative 3 times 2 gives me negative 6, and the x goes along. Here, negative 3 times 5 would give me negative 15. Then we finish the factoring. We pull that common factor of negative 3. That's what slides out front, what I could take out of both of them. What was left over, my 2x plus 5, is what stays on the inside.
You're going to run into problems if we don't change our subtraction sign to adding the negative in that problem. In our third example, we're kind of taking a look at 2 and 25 and asking ourselves, what are the factors of both? 2 is 1 times 2, 25 is 5 times 5. Mr. McKenzie, they have nothing in common, so our greatest common factor must be 1.
And in that case, there's nothing we can factor out of them. They don't have anything in common, so we just leave it alone.
Or you can write cannot be factored on your answer. That would be acceptable as well. But don't just get stumped when you see that they have nothing in common.
Well, they do have something in common. They have 1.
True.
All right, let's see who's really paying attention. You are going to copy down these 2 problems into your notes. You are going to factor them. Use the examples we just did to kind of look at how we break them apart and where each of those pieces ends up, and then be ready to show us those when you get to class tomorrow.
See ya.